Yep, this is check for understanding for 5.2. So question 1, right, consider drawing a card from a shuffle fair deck of 52 playing cards. So in a fair deck of cards, there are 52 cards, right? How many possible outcomes are in the sample space for this chance process? And what is the probability for each outcome? So you got to think, how many cards are there? There are 52 cards. So, there are a total of 52 possible outcomes, right? And each outcome has, what's the probability for each outcome? So each outcome has 1 out of 52, right? Probability of 1 out of 52. So next part, define the following events, okay? So event A is the card drawn is an ace. Event B is the card drawn is a heart. So part 2, right? Number 2, find probability of A. So probability of A is what's the probability of drawing a card that is an ace. So we got to think, okay, so how many aces are there in a deck of cards? So there are 4 aces, right? And out of a possible, how many possible outcomes? 52. So it's 4 out of 52, which is approximately 0.0769. So what's the probability of B, right? Event B happening, that the card drawn is a heart. So you got to think, how many hearts are there? So heart is a suit, and a suit has 13 cards. So 13 out of 52, which is 0.25. So number 3, right? What is the probability of A superscript C? So what does A sub C means, right? A superscript C. So that is actually, right, it means A complement, right? If you have A to the power of C, well, it's not really a power of C, but it's called A complement. Right? And another way to write A complement is A with the dash on top. Now, what does that mean? A complement means that is not A, right? There's an event that is not A, okay? So if A is event of winning a lottery, not A means event that is not winning the lottery, okay? So, and it's written as 1 minus the probability of event A happening, and which we found out from part 2 that the probability of A is actually 4 over 52. So if you convert 1 to 52 over 52 minus 4 over 52, and the reason why we do that, it's because we need to establish the same fraction, right? Same denominator. And that gives us 48 out of 52, which is 0.9231. Okay, part 4, are events A and B mutually exclusive? Why or why not? So we need to understand what mutually exclusive means. So mutually exclusive means that it has nothing in common, right? Does event A and B have nothing in common? Why or why not? So graphically, how would it look like when you're trying to say if event A and B has nothing in common? So that's how it looks like. With the event A and event B, it has no overlap. So when it has an overlap, it looks like this. So event A and B have something in common, and the shaded part in the middle is what is common in A as well as in B. So the answer is no, right? Event A and event B are not mutually exclusive. Do you know why, right? I'll give you a second to think about why do you think event A and event B are not mutually exclusive? Because when they are not mutually exclusive means that they have something common in between A and B. So a card can be both an ace and a heart, which is the ace of heart. All right, so this is 5.2, check for understanding. Concept 2. So question goes, consider drawing a card from a shuffle fair deck of 52 playing cards. So define the following events. Event A, the card drawn is an ace. Event B, the card drawn is a heart. So for number 1, use a two-way table to display the sample space. Okay, so we need to draw a two-way table, and we first draw 4 rows and 4 columns. Why 4 rows and 4 columns? You'll see in a second. So let's define, let's put our events into the box, right? Into the table. So if event B is the card drawn, that is a heart, and B complement is the event that a card drawn is not a heart. Okay? So then we put event A on top, on the first row. Event A is drawing a card that is an ace. Event A complement is the event that a card drawn that is not a heart. And then we put the total on the last column and the last row. Now, we know that there's one card that is both an ace and heart, right? That's the ace of heart. So if you look vertically in A column, right, the event that the card drawn is an ace. So with one card that is a heart, how many cards that's not a heart but is an ace? The answer is 3, right? So 1 plus 3, the total would be 4. And so then the next thing we need to look at is, so row B, right? The row that says the event that the card drawn is a heart. So if one card is an ace, so what is the event that the card is a heart but not an ace? How many cards would that be? The answer is 12, because there are only 13 cards in a suit, right? Suit of hearts. So total for that will be 13. Okay? Now we put 48 in the bottom row under the A complement. Why? Because if 4 cards are aces, what are the how many possible outcomes that are not aces? So it's 52 minus 4, and you have 48, right? So what's the event that is not an ace? The card drawn that is not an ace and is not a heart. So the answer is 36, because if you add up that column, it should total up 48. So 12 plus 36 should give you 48. So in order to find that middle column, all right, of an event that is not heart and not aces, we just take 48 minus 12, and that should give us 36. And all we have to do then is just total up, right? So 4 plus 48 is 52. There are 52 possible outcomes, 52 cards. And the total cards for an event drawn that is not, there's a card drawn that is not a heart, is 39. All right, number 2, use a Venn diagram to display the sample space. So if you think about it, how would you be able to create a Venn diagram that will be able to display all 52 cards? All right, if that's what we want to do, right, to display the sample space for all 52 cards. So, well, I'm going to just show you what I meant by a Venn diagram. So a Venn diagram is usually circles either overlapping or not overlapping. In this case, I'm creating three circles. And I need to define what those circles, what those events are, right? So the first event, aces, right? From our earlier the question, A is a card drawn that is an ace, B is an event that the card drawn is a heart. Now I need to define what C is. C is anything other than aces and hearts, right? I need event C in order to make this Venn diagram complete. So what's the first thing that we know, right? So we know that there are 4 aces, 3 of which are aces, but they are not hearts, right? So I need to put the 3 there and not in part of B, right? The one card that is an ace and a heart, I can put it right there in the middle. Okay? So if one card is an ace, how many cards there are hearts? 12 cards, right? 12 cards that are hearts but not an ace, right? So altogether will be 13 cards in a suit. That represents the event B, where a card drawn is a heart. And event A is an event that a card drawn that is an ace. So if you add up all the numbers in the circle, in the respective circle, you get, for 4 for event A and 13 for event B. And then you have 36 for event C. Now, do you know how I got 36? Actually, if you do the math, if you take 36 plus 1 plus 3 plus 12, it adds up to 52. And that is why the event in C, named other, right, is right there. So 36 outside the two is not overlapped by circle A and circle B, by event A and event B. So part 3, find the probability of A union B. Now that symbol, right, the U, we call it union, right? Call it union. Event A union event B. And it's actually, union is actually stands for all, right? Union stands for all. So union, when you want to find event A union B, there is a formula that we have to use, right? We call that the general addition rule formula. So it's probability of event A plus the probability of event B minus the probability of event A intersect B. That symbol, inverted U, it's called intersect. Okay, right? And that is actually A intersect B can be written as A and B, right? So it's like an event that happens in both A and in B. So this union, right, A union B, is graphically, it looks like this, right? You have A and you have B, right? A union B. And we know that A and B, there's an overlap. So if we want the probability of event A, we shade the whole circle event A. And if we want to add probability of event B, we shade the whole circle of event B. Now, guess what? We have just added the middle piece twice, right? The middle piece is this shaded area. We have just added it twice. So we need to subtract one time, subtract away, right, in order for this formula to work, right, to find the actual probability of event A or probability of event B, right? We cannot double dip, we cannot add it twice. So event A is 4 over 52, event B is 13 over 52, minus away 1 over 52, and that gives us 16 over 52, and that is approximately 0.3077. Okay, I would like to elaborate the general addition rule a little bit. So let's write out the general addition rule. So probability of A, event A, union event B is equals to probability of A plus probability of event B minus probability of event A intersect B. So now if you draw the scenario, the Venn diagram from our previous example, now those two events, event A and event B, are not mutually exclusive, meaning that they do have something in common, right? And the something in common is in the middle piece where it's the overlap, and that piece we call the event of A intersect B, okay? And so this is also a good time to actually review. Union means or. That means event A or event B happening. So when you say event A or event B, it means it can be in event A, or it can be in event B, or it can be in event A and B, right? So then the intersect sign symbol, which is the inverted U, that is and, right? So the event of A and B both happening at the same time. So in this scenario, right, there is overlap, right? It's not mutually exclusive. So there is a probability of event A intersect B happening. So another scenario, right, where it's the same formula, the same general addition rule, probability of A union B equals the probability of A plus probability of B minus probability of event A intersect B. But I want to talk about a scenario when it's mutually exclusive. That means when A and B have nothing in common. So if it has nothing in common, when you intersect, what is the probability of finding something, an event that is common between A and B? Is there any? There is none, right? So the probability is actually 0. So all you have to do is add up probability of A plus the probability of B, and that will give you the probability of event A union B.